Hello friends, welcome back to my channel Varteta Learning Platform, and in this series of tips and tricks in C++, we are going to discuss a very important concept, which is the virtual functions in C++, and about the polymorphism. Obviously, virtual functions are used for the polymorphic classes to create the polymorphic classes and to implement the polymorphism concept. So let's first discuss something about the polymorphism. What is a polymorphism? Polymorphism is something like one thing in many forms. Okay, just like there is a vehicle, this is a very common name for all the vehicles. The vehicles can be in the form of a car, it can be a truck, it can be a bike, it can be an auto rickshaw. Okay, so when one thing can be implemented in many different forms, then this concept is known as the polymorphism. Okay, so to implement this thing programmatically in C++, we use the concept of virtual functions. Okay, so how do we define the virtual functions? And many of you might be aware about that one as well. So if you are writing a class, say class sample, and inside that class, if you create some public or private whatever, suppose I'm creating a public virtual function using the virtual keyword, virtual void some function name, virtual void fun. Okay, so this class becomes a base class, a virtual function class. So this will become base class which will contain which is containing a virtual function, and this class can be inherited to to implement the concept of inheritance, polymorphism. Okay, suppose I write the class name as vehicle, not as sample. We just write the name as vehicle, and after that we start inheriting this class for various other classes implementation like car, truck, or whatever. In that case, we will be implementing the different classes, different polymorphic classes, right? So what about these virtual functions? Why we create these virtual functions? Basically, we create these virtual functions to indicate the name of those functions, or you can say to indicate that kind of functionality. That functionality is everywhere in every class, right? Like if we talk about the vehicle, then that vehicle is using the fuel, okay, and that vehicle is also having the number of a number of tires, the kind of engine it has, right? So everything has a different kind of engine. Every other vehicle is using the fuel. So there may be some functionality like the number of the number of tires, or you can say the type of engine. So engine, the starting of engine may be different for car, starting an engine for a truck may be different, a process of starting an engine for bike, or the functionality of engine may be different for the bike, and the same is true for auto rickshaw as well. The functionality may be different for the engine, right? So this can be something like a start function. Rather than giving a name fun, we can give a name start, virtual void start engine, right? So this start engine had some other implementation for car, it has other implementation for truck, it has other implementation for bike, it has somewhat different implementation for auto rickshaw. So the functions which needs different implementations in different classes, or you can say for the different polymorphic forms, in that case we define that particular function different. Okay, we can take one more better example. The better example is like we can have a class named shape, okay, and inside the shape I can have a function like draw, okay, virtual void draw. Draw is a function which will draw a particular shape, and this draw function is true for every other shape, because every shape When we draw it, then only it will be visible, right? So we are going to draw the shape, any shape, right? So I have created this function as virtual because drawing a line, drawing a circle, drawing a rectangle, everything, every other polymorphic instance like line, circle, rectangle, which will be inherited from the shape. Everything is a shape. Line is a shape, circle is a shape, rectangle is a shape. So everything is a shape, but drawing them is different. Drawing a line is different, drawing a circle is different, drawing a rectangle is different, right? So every other class, suppose we are going to create a class line, then in that case we need to inherit this class from public shape, from shape class, right? And inside this shape class we need to write our function void draw. We need to implement at our end. We need to find out 2 points, provide first point, provide second point, and then you will write the functionality to draw the line between the 2 points which have been mentioned. Similarly, you can for this circle you can write a draw function. That draw will be different because in that case you will find out the radius of the circle. You will ask for the radius of the circle from the user and then you will draw it. So everywhere, if for every other polymorphic instance like line, circle, rectangle, in case of shape, the draw functionality will differ. So whatever is a common functionality but the implementation differs, all that functionality we put in a form of a function, and that function we make virtual. So I hope you now got why we will create a function virtual. It's not like you can make any function virtual. It should make sense. So now you will be able to decide when it will make sense for you to declare a function as virtual, right? You are not going to declare any function as virtual without any reason and just for the sake of the fact that you know that there is a virtual function concept. Just for the sake of fun, you are not going to do this, right? So all these concepts need to be clarified at the core of your understanding, right? So once you are able to understand these concepts, where you use the virtual, where you really use the virtual, then you will be able to decide whether you should be able to use the virtual function or not. Okay, so in case of deciding this virtual function, why this is important, that we will discuss in the next videos. In the next video we will first discuss like how these virtual functions are maintained by the runtime, how the compiler compiles them, and how at the runtime it is decided that what function will be called. Okay, so let me tell you, this is when we implement the virtual function inside a class and we implement the polymorphism, then this kind of polymorphism is called as dynamic polymorphism. Dynamic polymorphism. You might have studied about the static polymorphism as well. Static polymorphism is shown by the function overloading. Function overloading is an example of static polymorphism. Okay, and when we create polymorphic classes, we create a base class where we have a virtual function and then we have number of classes inherited from it. Then that kind of polymorphism we do, that is known as dynamic polymorphism, because at the runtime we decide what function will be called, right? At runtime, based on the type of object, vehicle is pointing to a car, then the car's function will be called. Or you can say if you are using the shape class, then based on the type of shape, what shape is pointing to, based on that it will call the respective draw function at runtime, right? So all the decisions will be made at runtime in case of polymorphic classes. So that is why it is known as the dynamic polymorphism. Okay, so in the next video we are going to discuss like how at the runtime the function call is decided. Okay, so till then, have a nice day and bye bye.